Quantitative Genetics. Since I've been stuck at home, I've decided to improve an interesting population of platypuses. I think their tails are too short, so I'm going to take the top 10% and breed them for longer tails. My original population of platypuses has a mean of 5 inches and a standard deviation of 2 inches, with a broad sense heritability of 0.82 and a realized heritability of 0.67. I've decided to breed the top 10% of the population, which gives me a standardized selection point, Z, of 1.282 and a selection intensity, I, of 1.755. These will help in our calculations to find the truncation point and the selection differential. To get the truncation point, we have to set x sub t to the original mean plus the standardized selection point times the standard deviation. This gives us a value of 7.564 for our population. Next, we will solve for the selection differential, which is the selection intensity times the standard deviation, and we get 3.51. This will help us calculate and find x sub s, which is the mean of our selected individuals, which we don't yet know, and r, which is the response to the selection. To find the mean of the selected parents or individuals, we are going to set s equal to x sub s and x sub 0 minus x sub 0. We know x sub 0 and s, so this helps us find x sub s, which is equal to 8.51 inches. Next, let's calculate r using realized heritability and s. So, h to the second is equal to r divided by s, so r is equal to h squared times s, which gives us 2.35 for our response to selection. Lastly, we want to know what's the average tail length of our offspring population that we breed. Well, to find out that, we will set r to x sub 1 minus x sub 0. We find by doing some simple math that x sub 1 is 7.35 for our offspring. Here's a graph, specifically a histogram, to look at our values and figure out what they mean. So we have x sub 0 here, x sub 1, x sub s, our response selection, and our truncation point.